Hi everyone, welcome to this tutorial on Bifrost for Maya. We are going to look at how you can create interesting eroded forms like this column using level sets. And while this might look quite complex, it's pretty easy to set up. So we're just going to dive into it. And by the end, you should have, if I can focus on this object, a very interesting eroded column. And we'll start with a very simple shape and then get all of these complex ins and outs. So let's just jump into it. All right, let's go step by step from a blank Maya scene. I'm going to start by making a cylinder. And in the attribute editor, let's change its properties using the creation node. We'll make the radius 4.5. We'll make the height 20. I will make the subdivisions along the main axis 30, and let's try to get subdivisions along the vertical axis that are roughly square, so 25 is looking pretty good. And then we'll try to get some approximately square or squarish things on the top, polygons on the top. That's looking pretty good. Let's go ahead and move this up and sit it on the origin, and so I'll translate it to 10. And now we can center the pivot, delete the history, and freeze the transformations so that we have an object that's ready to go into Bifrost. I'm also, with the channel box open and the layers revealed, I'm going to hit this rightmost icon that will put my object on a layer. I'll call that something straightforward like cylinder, hit save. I will template it. Let's see, did this not go into that object? I guess I didn't have it selected, so I can select the object, right click, add selected objects. And now with the T variable selected here, I can make that ghosted, which is helpful because I can see where it is, but it's not going to interfere with what we're doing in Bifrost. All right, let's start Bifrost. You can access Bifrost here in the windows, find the graph editor. I have mine parked over on the side here with the other tabs, and I will create a new graph, hit F to focus, delete this input, and grab our cylinder here, and middle mouse button drag it over into the Bifrost window. Okay, so now we have our cylinder, we're ready to go, and we need to turn it into a level set. So I'm going to hit tab and mesh to level set. And this is going to turn it into a volume. And again, a volume is an implicit surface, which is based on a voxelization of whatever the input is. Could be a field, could be geometry. In this case, it's our mesh. And we can see that voxelization using tab, the voxel scope. Oh, I'm sorry, it is called the volume scope. The volume scope will show us the voxelization. Before we show that voxelization, let's bring the detail size up a little bit. So from 0.05 to 0.5, now let's plug our level set so you can see what's going on here. So it might be a little bit small. So zooming in, grab our level set, throw it into the volume, and then we need to be able to see it, and we can do that with a terminal. So I'm always hitting tab to get the components, and now I can preview my volume scope. Why isn't it previewing? Let's move. What am I missing here? Let me pause the video for a second. All right, well that was dumb. It looked like I had it plugged into proxy, but I had it plugged into final. So there we go. Now that I plug it into the right input and toggle on the display, I have it in proxy, I can see the voxels. And so this is how the field, or I'm sorry, the implicit surface, the volume is being created. And if I go back to the mesh to level set and make this detail size smaller, like 0.05, where it was originally, you can see I get this like super dense sampling of the geometry. So the resolution will be much sharper, but we have to be careful because we want the resolution that is adequate for our object, but we don't want it to be so dense that it crashes our computer and makes our computer run out of memory. So I'm going to start with a value of 0.5, and we can make it lower if we need. Okay, so now we need to turn our level set into, before we preview it, we need to turn it into a voxel field. And we will use the tab voxel field component for that. And why do we need to turn our volume into a voxel field? So that we can remix it with a noise field. So if we type tab or hit tab and grab a fractal noise field, we will be able to use this field as a mask to carve out our voxel field. And we can't do that if it's just a normal volume. We have to turn it into a voxel field, then we have to mask it, and then we can turn it back into a volume and then into a mesh. So let's do that. So we have our fractal noise field, the settings, let's make the magnitude 5 and the number of frequencies 3, that's fine. Maybe the frequency itself could come down to 0.3. We can always play with these things later. And then we need to turn this into a mask. So we can get the mask field component, plug our noise field in. Then we can grab a multiply component, and we can multiply our voxel field, which is the mesh, with the mask field. And now this is going to give us a voxel field that we can turn back into a volume. And that component should be volume, or let's see, voxel field. Let me find the component here. Okay, hitting the tab key, that component is called field to volume. Plug this in. Now we can turn our volume into a mesh. Tab, volume to mesh. And we can plug this in here. And we can hit the preview or the proxy, and we see that something pops on over here. It's not very impressive yet, but let's fix this. First of all, looking at our field to volume. Because we've been working with level sets, we should probably keep working with level sets. Let's unclick the fog density and click store level set. We can then come to our back to our mesh to level set, and this is where we had the original detail size. You can see that this is looking pretty primitive, and we're going to fix that in a couple of different places. First, let's try by bumping our detail size back to 0.05. That tightens it up, so that brings it more within the boundaries of our cylinder. So that's original cylinder, that's good. We have another problem here, and that problem is that only half the cylinder is being filled with the volume. And that we fix back in the field to volume component. If we scroll down, we will find a boundary section, so a minimum and maximum boundary. And what's happening here is that we're taking our original level set, we're turning it into a voxel field, and then when we turn it back into a volume, this component is going to sample a specific area in our modeling space. And so we need to know where our object is, and we need to then tell this component where to sample the field to create our object. So you can see here that it's getting part of it because it's doing this 20 unit cube around the origin. But because we put our cylinder on top here, we need to increase the max bounds up to 20 at the top, so that we capture all of our cylinder. And if we wanted to be really efficient, we could take that to 0, and that's tightening things up a little bit more. So that's looking better, and now we can continue to sample this. So the detail size here, we're in relative mode, and that's fine. This is the second time I'm recording this tutorial because I accidentally ran out of memory by making this detail size. So you can use this with a slider with the left mouse button, but you have to be so careful because if you make this number too small, it will crash Maya very quickly because it's creating too much detail and you can run out of memory. So let's try a value of 0.01. And you can see that suddenly our mesh is really, really dense and we're getting a lot of nice detail. So let's turn off the polygon preview for a moment, just so, oops, not that, but where are you? That should be, hold on. Here we are. Turn off the edges. That's better. Okay, great. So now we can see all of the erosion that is happening to our object, and we can continue to tweak this. If we come back to our original mesh to level set, we have our detail size at 0.05, so that should be plenty. We can now play with the resolution of our mesh and also the way that it's being sampled. So for example, we can, in the level set threshold in our volume to mesh, try a lower number. If we make it higher, it's should pop out, and you can see that it's getting more area than we need. So it's getting actually outside of our sphere, and it's making our sphere, our cylinder area a void within that. So that's kind of interesting, but it's not what we want. If we take this back to 0, we're getting our cylinder. And then if we start dialing this down, let's try negative 0.5 and see what that does. Now you can see it's starting to shrink it in, and it's also attenuating our erosion here. So let's take that back to 0 so you can see the difference. So now it's really pressed up against the cylinder. And if we start dialing this down, the levels, making this lower, tweaking it just a little bit, it's nice because it smooths it a bit and it's bringing it completely within our cylinder, and we're getting really nice erosion. So you can tweak the output with this level set threshold. We can also, let's see, here in the offset, within the field to volume, we can look at that. So let's see what happens if we make that one. That makes it blobbier. And if we take this to negative 0.5, that's eroding it more, so too much. But the offset is another place where we can tweak our erosion. So let's take this to maybe negative 0.05 and see what that does. And this is giving us a nice eroded quality inside of our cylinder. So let's go back to the original fractal noise field, because this is another place where we can dramatically change things. We can change the frequency here. So if I make this lower, so it's at 0.3, if I make this 0.03, now it's just a little bit of erosion. We're seeing a little bit of erosion here. Now let's start dialing this up. It's going to be a little bit slow. So 0.097, we're getting some, so basically the lower this number, the larger the shapes will be, and the larger the voids will be. So we can look at this as 0.1 is going to give us one type of erosion. That was pretty close. 0.2, let's see what that gives us. Now we're getting more erosion here, and we can play with the ratio here. That's going to tweak things. Okay, so if we give this more, if we make this ratio value higher, we're getting more little shapes. Let's take this to 0.1 or 0.5. Maybe looked pretty good. And if we go above 0.5 to say 0.75, now we're getting smaller shapes. So that's looking pretty interesting. And then our frequency ratio, let's try that at, let's see what happens if we go to 0.75 with this one. Okay, the frequency ratio going up seems to give us larger shapes, so we can dial that down a little bit. And again, a lot of this is just experimenting with the values to get something interesting, something that you like. So I'm going to just play with this frequency ratio a little bit and say, okay, I want something like that. And we'll be able to tweak all of this a bit further down the line too. Let's see if we can step this away from the, let's see, the edges of the cylinder a little bit more. So we have our offset here at negative 0.05. What if we made that negative, and this is in our field to volume, what if we made that negative 0.1? That's not changing much. Volume to mesh, level set threshold here. If we change that to -5, what would that do? That steps it in, but too much, so -2. Kind of steps it in away from the cylinder. But what we're really getting is pretty, I'm just hitting undo. We're getting a pretty even kind of pressing of this form against the outside shape. And I think that's something we'll probably want to change in the next step. So let's maybe change this one more time. I'm going to play with that, maybe take that, 0.1 is way too high, so I'm going to take that to 0. And field to volume, I don't want to play with this too much to make this video too long, but if I make this offset maybe -2, do I like that? I think it's going in the wrong direction. Let's just make that 0. I liked it better at -0.1. 0.15, let's try that. I can live with that. I think that's looking pretty good. And we'll just roll with that. And then of course you can continue to play with this. Another thing you can do is once you have a noise field, you can not only play with the settings of the noise field, but you can also introduce an F curve. And the component that we want is hitting the tab key, F curved field. And the F curve field will allow us to tweak this further with the curve. I'm going to come to the attributes for this. I'm going to click on the curve. I'm going to grab a preset curve and grab the linear curve going up, and that's just our baseline. But then when I pull this down, it should start changing our field, and I'm really surprised that it's not doing anything to our field here. Did I not grab it? It's not changing at all. That's really curious. Do I not have it plugged in here? Huh, that's really, really odd. Let me try one of these other preset curves here. Preset curves. Preset curves, let's try something like that. Okay, that's cool. Now you can see that this has really changed how our curve is being sampled. And if we pull this down, it could be that it's just taking it a moment to calculate. I'm really surprised that we're not getting some sort of, okay. Could just be taking some time for it to update. I'm surprised that this is not updating more in real time. Huh, really interesting. So it should be updating more in real time, but that could be just because the video is not being, the recording software is maybe slowing it down or something. So we try that, bring it back to this. Huh, maybe it's just not big changes. Anyway, that's looking pretty interesting, but I like the more eroded field here, so I'm just going to stick with that. So let's go ahead and proceed to the next step, which will be bringing it into Maya and creating our corroded, or rather eroded column. All right. Plugging this into the output here, I'm going to right click, create my Maya mesh. I'm going to hide Bifrost now, Shift H, or Control H rather, and that's going to hide Bifrost, and now I just have my mesh. And then with the poly modeling tab open, I'm going to center the pivot, delete the history, freeze the transformations, and that's going to break the live link between our original mesh and, or I'm sorry, our Bifrost and the mesh that we've inputted into the Maya scene. All right, I'm going to go over to the channel box, hit F to focus. I'm going to grab our cylinder, even though it's templated here, and I'm going to hit Control D to create a new one. And then, because that's going to automatically inherit this layer, I need to right click and remove selected objects. And now I have this cylinder. And so what I need to do is merge this cylinder with the mesh underneath. And the way I'm going to do that is by deforming the sphere. And I could do it with soft select, but I think the way that it will be good to show you to do this is to put a lattice deformer on it. So we are with the modeling pull down selected here. We're going to find the deform tab. We are going to create a lattice deformer, and by default this is going to put a cage around it. If you're a Rhino user, you might know cage edit. And the nice thing about Maya, because it's parametric for the most part, we can grab our cage and open up the attribute editor, look at the shape node, and we can continue changing our divisions or adjusting our divisions here. So we can give this a few more divisions in all of these axes, so maybe 5 in that direction. Yeah, I think that's looking pretty good. So 5 in this direction, 6 in the vertical axis, and 5 in the other horizontal direction. So this is going to look pretty good. And if you're not familiar with the lattice deformer, what I've done is by selecting this object and then creating the lattice, I've put this low resolution cage around it, and now when I hit the right mouse button, I can select lattice points. And my strategy here will be to grab the points and then hit the W key, E key, R key for scale. And I'm going to scale this column in. So what this lattice is doing is making it really easy for me to kind of get some control over how this column is getting scaled. And I can also scale it. Maybe that would have been smarter to begin with, because scaling it uniformly, pull it up, but I'm going to pull it down a little bit. But what you can see is that I am, by taking these points in, I'm scaling our original column. And I'm going to make it skinny so that I can even move it around. You can do all sorts of things with this. R for scale, I'm going to make it even skinnier. Just depends on how much you want to erode it. We can do some fun things just by grabbing these points and moving them around. So I could kind of pull that one down so it doesn't have to all start eroding in the same spot. I could, again, you could tweak this as much as you want. I'm just going to kind of randomly pull these things around and down, and that's going to look pretty cool. I can grab some of these points. Be careful not to select my other object. Right click. If you lose the points, you can get the points back, and I'm going to select these points. I could pull that one in, and again, you can get really interesting results just by kind of sliding all this stuff around and mixing these things together in an interesting way. So let's say that that's going to be pretty good. I'm going to now actually throw this back into Bifrost and merge these shapes. So how will I do that? I would like to keep this set up with a cage edit so I could edit it further, perhaps. But to make our new Bifrost shape, I'm going to hit Control. I'm going to grab both this mesh and the deform mesh, hit Control D to grab these things. I'm now going to, in the modeling toolkit, combine them into one mesh. We could always separate them again. And now I'm going to go back to Bifrost, and I'm going to create a new, I guess I could just do it in this one. Maybe that's easier. I could create a new graph in the scene if I wanted to mix them. And maybe let's just do that, just to show you that you can have multiple graphs in the scene. So I could rename this one let's see, Bifrost, let's see, Erode. And then I'll make a new one, so a new graph, and I'll rename this one Bifrost Combine. And now I'm going to grab this mesh, middle mouse button, drag it into Bifrost, And now we need to turn this mesh into a level set. So mesh to level set. Can grab it. And that's going to turn it into our level set volume. Let's go ahead and bump up the detail size to 0.5. And let's also grab this object and hide it. And now we can mesh to volume. We don't have to turn it into a voxel field this time. We're just using Bifrost to merge these objects. And now we need to volume to mesh, the exact opposite. So volume to mesh, turn this back into a mesh. And let's grab our level set, hit P. And now you can see that we have combined these objects. Okay, so we're losing a lot of the detail, and this is where we can play with the settings. So the first thing we might want to do is go back to our detail size in the original mesh to level set component and hit 0.05, see what this gives us. Now you can see that it's taking quite some time to calculate, or maybe you can't see it, but I can feel it cranking. So hopefully that, great. So I can see now how it's turning into a volume. Clearly that is like, I mean, it's interesting the way that it's really capturing the polygons of the cylinder, but it's too sharp, right, for creating a more soft transition between the two shapes. So let's go back to our mesh to level set and change this back to maybe 0.1. Let's try that. We had 0.5, now it's 0.1. And that's looking better. Let's also just try this at 0.5. That's where it was, maybe 0.25. Again, you have to play with these. What I'm trying to do is lose some of the sharpness here before we further refine it with the level set threshold. Okay, so now under volume to mesh, let's make sure that everything's looking pretty good here. We can change the detail set size here. So this is going to give us a tighter mesh if we take this from 1 to 0.5. And then maybe we can see that a little bit better if I turn on the wires, the edge wires here. So we can see how it's being calculated. So this is looking pretty cool, but I want to maybe make it even a little bit more refined. So let's go ahead and grab that. And you can see that we're losing some detail in here. So how are we going to get that back? Well, we could, let's see, under the detail size, we could continue to play with the mesh to level set. And we could, so we see there's this thickening ratio here. We could see what happens if we take that off. Okay, this is actually pretty interesting because this is eroding our column much more. And so the thickening is not just about offsetting the whole mesh, but how much the level set gets thickened from the input objects. So by default this is 1, but if we start making this a little bit lower, let's take it to 0.9. Let's see what happens there. It's starting to sharpen a little bit. 0.8 and 0.5. At a certain point, we are going to get more, more erosions and holes in here. We can also play with this minimum hole ratio. That's something that can be kind of interesting. 0.25. Let's see, yeah, okay, so now we really get more things opening up here. So that's pretty interesting, another way that you can play with erosion. If we have these holes opening up, I'm wondering now if we hit if we set that to 1, you can see that it'll start to close it back up. So by playing with this minimum hole radius, for example, 0.1, we can actually, kind of tighten things back up. So this is now looking pretty good. It's both sharp, we have quite a bit of detail, it's looking a lot like our original one. We could keep playing with this. We could take the detail size maybe down to 0.15, see what that does for us. Do we capture more? Yeah, now we're getting more of that original detail. This is looking really pretty good. Maybe we want it to be a little bit thicker, and that's looking, I think, pretty good, and we could now go back to our level set threshold here. Now, if we, at the very end, volume to mesh, if we, so mesh to level set, the detail size, okay, yeah. Then here in the last step, volume to mesh, we can either make this blobbier by making this number larger, so that's a little too large, so 0.5. Give it a positive value, it's going to expand it out. So that can give us an interesting result. Let's go back to the baseline of 0. Now let's take this to negative 0.8 and see what that does. So this is cool because now you can see that it's really carving our object. It's carving it a bit too much, but if we raise this back up, right, you can see that we get all of these interesting kind of shapes and cracks. And so you can get like a really different type of erosion here, a more extreme erosion. I'm going to take it back to 0 and then dial it down a little bit. So what if we try like negative 0.8? Let's see what that gives us. Too much? So I think I need to be doing this like that, negative 0.1. Okay, yeah, so that's going to give us kind of what we have, and then if we just step this up gradually, we can see what happens, and we get more erosion here. So that's pretty cool. And then with our detail size here, we could also make this smaller and capture, that's going to make our mesh a little tighter as well. And I think that this is all looking pretty good. So let's take this up to 3. Does that erode it too much? Maybe that erodes it a little too much. And so I'm going to just take it back to negative 0.15 so we don't get too many fragments. And I'm going to say that that's looking pretty good for our erosion. I want like negative 2. Okay, I don't want to go too obsessive here. Okay, I played with it a bit further, and I think what I decided is that what I don't like is how it terminates in this cylinder in here. So to fix that, I don't need to do much. I think what I would just need to do is, now that I have this all set up, it's very easy to swap this all out with a new mesh. So I think what I would do here is grab our lattice deformer again, right click, turn on the points, appear lattice point. I'm going to take these points, hit R, and I'm just going to scale them way down, like way down, so that we get, we don't hit that surface so quickly. And now let's grab these two things, Control D to duplicate them, drag them over. We will, we could do it in the modeling toolkit, or we could go to mesh combine, put these into one mesh. I'm going to bring this over by middle mouse button, dragging this into Bifrost. Then I'm going to hide this shape, and I am going to bring this in and just swap out our original shape for this one. And this should update right away. Why did it not? Oh, I think it's because, did it update? I think it, yeah. So this is a little funny because I moved the graph over, and so that should be the new shape. Let's just double check by pulling that one in. Yeah. So this is the original one, and then the new one is that one. And it's much more eroded here because I've pulled that inner cylinder in more. So if I compare these two, this one has this kind of central shaft that's not bad, but I want it to be more eroded in the middle, and so that's looking more interesting to me. Okay, cool. So it's very easy and flexible once you have this little script to set it up. And now I am going to bring this back into Maya, the modeling world, by throwing this into an output, right-clicking, creating my Maya mesh. And it's funny, it creates it back over here. I'm going to center the pivot, delete the history, freeze it, so it's no longer tied to Bifrost. You have to be careful moving the Bifrost graft. And now I have this guy. So what I'll see is that I have some additional fragments here. And if I wanted to texture this, adding Arnold materials to give it that micro texture like the one at the beginning of the video, I'm gonna need a nice mesh to do that with. And so the process for that, I covered this in the last video, but very quickly what you would want to do is go to the modeling toolkit, separate this. This is going to give us all of the meshes, little meshes that would be in this thing. I just want the big one, and the rest of them I'm in the group for these meshes. I can just delete those. Maybe there's another one that you want. You can make that decision. Then I'm going to grab this mesh, go to Edit, Ungroup, get rid of the transform, and now I have this clean mesh. Okay, this is not great for texturing, so what I would want to do is use the mesh retopologize, and that can be found under mesh retopologize, and we're going to want to turn this from a triangulated mesh into something something that is has a nicer quad topology. So before you run that, two things: go to display, heads up display, find your poly count, and turn that on. And let's query or look at this object and look at how many faces it has. So it has about 100,000 faces. We're going to probably need that or a little bit less in order to capture the resolution of the object. So keep that in mind when you retopologize. Then you can go to Mesh Retopologize, grab the little box here, and change our target face count. I'll make it a little lower, something like 80,000 maybe. And I'm going to unclick preprocess mesh for this. And because retopologize can take quite some time, you want to, under Windows, bring up the output window, because this will show you the process for the retopolizing, that's the better word for it. And because it takes a long time, you can think that Maya has stopped, and you can give up and hit escape or close the program when in fact it's still working. You still probably want to hit save at this point. So save your file and then run the retopologizing, and that will give you nice smooth quads. I'll go ahead and hit Windows or Mesh, retopologize. I'll pause the video and we'll come back and see what it looks like. So it's not finished yet, but I wanted to show you what the output window looks like when it's running. So this will show you that it is in fact processing the mesh, and then I will pop back in when it is done. Okay, we're done. It took a couple of minutes, but this is our nicely retopologized object. Great and ready for texturing. The one thing that you also need to do once you're happy with the retopologizing of the object, please remember to center the pivot, delete the history, and freeze the transformations. Deleting the history is the important thing, because if you don't, and you, let's say, close the file, the retopologizing, which takes quite a long time, will run all over again. And that will make you very cranky. So I hope you've enjoyed this tutorial, and look forward to making some new ones for you in the future.